So we're going to look at the Fischer esterification. A Fischer esterification is when you start with a carboxylic acid and you add an alcohol in the presence of acid to get the corresponding ester. Now, keep in mind that the alcohol is a weak nucleophile, so it won't readily attack our carboxylic acid. We first need to activate the carbonyl by protonating it in these acidic conditions. However, the sulfuric acid isn't going to protonate the carboxylic acid directly. Typically, what we're going to see is the alcohol, our nucleophile, is actually going to get protonated first to become an acid that could then protonate our carbonyl. So the lone pair from the carbonyl is going to remove a hydrogen, and we're going to get the protonated carboxylic acid here. Now that the carbonyl is protonated, we can then add our weak nucleophile to the carbonyl, and what we get is the structure here. Keep in mind we're in acidic conditions, so you're not really going to see any negative charges. So we can't just lose OH groups. We have to create water first and then lose the oxygen. So before we can do that, though, we typically need to satisfy charges. When we added our alcohol, we don't add it as O minus, we add it as the alcohol itself. So it's going to have a positive charge once it added. We need to get rid of that, and we do so by removing the hydrogen. So what we need to do next is use our alcohol as a base and deprotonate that oxygen. And we get this neutral product here. Eventually, one of these alcohols or OH groups need to leave. They're going to leave as water. So we need to protonate it before we do that. Because as I mentioned, we can't let that leave as OH minus because we're in acidic conditions. So we need to add more acid. We have a plenty of acid present. So more of our protonated alcohol that we just generated is going to protonate our oxygen there. And I actually showed it protonating the other, so let's actually kind of stay consistent here. We're going to remove that hydrogen, and we have our leaving group, which is water. Now, water isn't going to just spontaneously leave and leave us with a carbon with an incomplete octet. What we're actually going to do is reform our double bond and then kick out the water. And so we're going to get our carbonyl back, but it's still going to be protonated. So what we need to do in our final step is deprotonate. Whoops. We need to deprotonate with our alcohol. So the Fischer esterification is just a few steps. Keep in mind we are substituting this with this, so we need at least one nucleophilic attack and one loss of a leaving group. Everything else is just proton transfer to get the correct charges or activate electrophiles. Again, the first step is protonating our carbonyl so that we have a good electrophile. So that is a proton transfer step first. We then do a nucleophilic attack to get our ester piece on there. It is currently protonated, so we need to do a proton transfer to deprotonate it back to neutral. Now we need to get one of our leaving groups on there, so we need to protonate one more time, proton transfer, and now we have our good leaving group. We do our loss of a leaving group step. We regain our carbonyl, but we are still protonated, so we have one last step, which is a proton transfer. So you can see the Fischer esterification is almost alternating. We have proton transfer, nucleophilic attack, proton transfer to get to neutral, proton transfer to get our leaving group. We have loss of the leaving group, and then we have our proton transfer to get to our final ester product. Keep in mind, these are reversible. If I have water present instead of the alcohol, I can actually make this go in reverse, and the ester can go back to the carboxylic acid. It's essentially the same steps. I would just protonate to get to the protonated activated carbonyl. I would then add water this time to get to this structure, remove the proton to get to neutral, protonate the ester piece. I would then do loss of a leaving group to get to the carboxylic acid with the protonated carbonyl, and then a proton transfer would get me back to the carboxylic acid. So Fischer esterification can be reversed if you add water and remove the alcohol. The next video I'm going to do, I'm going to show a Fischer esterification, but a cyclic intramolecular version.